Okay, let's get started with example 2 then, right? Now, this being the second example, at this point, you should hopefully have tried the problem. If you didn't try the problem, right, go and try it. Hit the pause button now. Go and try it on your own, and then come back and take a look at my video if you're really having some trouble here in completing the problem. Right? That's what we always want to do. Watch me do the first one, and then the second one. Then you kind of use it as needed. Okay. So here we go. So an object is thrown from an initial height of 10 feet with a velocity of 96 feet per second at an angle of 30 degrees from the horizontal. Okay, so this is a different type of problem. Not the same type of problem. We're not spinning around a wheel here. So this is totally different. So, right, let's see what we can do. Okay, so let me model this. So, okay, initial height of 12, right, for ourselves, and okay, and I'm sorry, 10. 10 feet is our initial height, okay? And we're going to model the path of the ball. Okay, so let's think of what we're going to have here, right, for ourselves. Oh, it's an angle of 30 degrees off the horizontal, okay. There we go. So that's the initial path, just like that, okay, for ourselves. Okay, so if we're thinking about this here, right, there's our initial velocity, and there's some equations that you may or may not be familiar with as you do these ones. Okay, so one of the equations that you need to become familiar with is the x one, because the x, we're moving in this direction here. We're going to think about that x for ourselves. Okay, and if we think about this, right, while it's going up this way at 96 feet per second, if we think about what we're just doing with vectors, then this is going to really make sense for you, right? Because you can say, okay, if we were going flat, it would be 96, but we're losing some of that x direction there because of that angle of 30, right? We're traveling this way. We're thinking about the horizontal. We're traveling this way, so that's why we're going to have the cosine of 30 degrees as our. So 96 cosine 30 is actually how much we're moving. That's the adjacent side there, right? And that's times t for the amount of time that's passed. Okay, so in 1 second, right, we are going to go 96 cosine of 30. That would tell us how far we went, right? In 2 seconds, so you would just work from there. Cosine of 30, obviously, because I gave you 30, that's a nice one. We should reduce it. I expect you to reduce it. So that being root 3 over 2 using your trig values. That's going to give us 48 root 3 times t, right, for ourselves. Okay, so there we have our equation there for the x values, right? So now the y equation. Now this is definitely one that you probably haven't seen. Maybe you remember it from last night's homework, right, as we were doing it, right? And right, here's our equation there. So here's what we have. First of all, we have our initial height, right? So I'll start with that. So h sub 0 is my initial height, okay? And then we have to keep in mind gravity. Gravity is going to be pulling down on this because we're going up. So that's my gravity, minus 16t squared for myself. Okay, then we also have to think about that y component. So now we can actually account for the horizontal travel. And so just like we did up here, right, we're going to use what we have 96, but our vertical, right, is going to be going this way. That's going to be using sine for myself. Okay, and that's for the amount of time that passes. Okay, so this right here, the h sub 0 is my initial height. Okay, the negative 16t squared is gravity. Gravity's effect. Okay, and then that last part, this is actually what's happening. So if we're in a gravityless environment that we're worrying about, we would get rid of this. If we were shooting it off the ground, then we get rid of that, and we would just have the same exact thing we have for x. But it's not gravityless. We're dealing with gravity. We live, we basically, because we exist, we are going to have to deal with gravity. Okay, so the height is 10. Oh, that's 1/2, so we're going to put 48t there. So sorry about that. Right, there's my equation for myself. T is in seconds. Is time in seconds. Again, these parametrics, especially with the word problems, make sure you label what you have there. So those are my two equations. Write a set of parametric equations. There's one, and then there's the other for myself. Okay. So, okay, what's the maximum height? which of these two equations tells me height? That one tells me height. I'm going to use that one, right? And so I'm going to use that equation. And I'm going to change it so that it's in standard form here, because then that will ring a bell as to what we're going to do, hopefully, as we do this, okay? So there is my height equation, right? So we, right, before we actually can find the maximum height, we need to figure out when that occurs. And if we think about this graph is a parabola. And a parabola, it's opening down. Opening down. I can't spell. So, okay. So if the, roughly speaking, it looks something like this. Okay. And the maximum here, this is the maximum. It's also your vertex of your parabola. So it really helped that we're dealing with a quadratic equation here. So we need to basically find our vertex. That's all this is really asking if we put it back to algebra 2. Right? So you may or may not remember that to find the vertex you do negative b over 2a, right? And that will give us the x value of the vertex, right? And so that's one of the reasons I changed this to standard form. Negative 48 over negative 32. We reduce it down and we get 1.5 seconds. So not our answer, but it's the time that it will actually hit its vertex. And so we're just going to take that and plug it in, right, to this equation over here. And because I love fractions and I hate using calculators, right, I'm going to put it back to this. Right, so I'm going to take that and I'm going to plug that equation, I'm going to evaluate it. Right, I'm going to take that y equation and evaluate it when t equals 3/2. That straight line tells you to evaluate. Okay, and I'm going to plug it in. And so I got negative 16. 3/2 squared is 9/4, right? Plus 48 times 3/2 plus 10. Okay. Hey, these are working out really well. So I have negative 36, right? Plus 72 plus 10, 46 feet. Right? There's my maximum height for myself. Okay. Right, as we deal with this problem. Notice x has nothing to do with that problem because x is all about your distance left to right. It has nothing to do with the height there. Right? So if we wanted to find the height, or I'm sorry, if we wanted to find the location, how far away it hit its maximum height, you would take the 1.5 and plug into the x equation, and that would tell you how far away from the launching point you would stand to actually be right underneath the peak. Okay? So go to C. How far will it travel horizontally before it hits the ground? Okay. Now, in some of these, sometimes people say, "Oh, I'm just going to use the symmetry, and I'm just going to say, oh, it's going to take twice as long, right, to hit the ground." And that works in some cases, but it doesn't work if your initial height isn't 0. So I really would highly suggest not doing that. But remember, how far will the object travel before it hits the ground? Okay, right? We want it to hit the ground. So it hits the ground. That means y equals 0. Right? That's the important thing to know. So I go back to that equation. Right? I set it equal to 0 there. Okay. Now I'm hoping it's going to factor. I'm doubtful it's going to factor, but let's at least try to see if we can divide by any common term there. I can divide everything by 2. Okay, and okay, I'm not thinking that's factoring. So off to the quadratic formula we go. So negative b plus or minus the square root of b squared minus 4a c all over 2a. Okay, put it into your calculator and you go from there. And you're going to get 2 answers for yourself, right? One of the answers is going to be 3.196, and the other one's going to be a negative answer. It's going to be like negative 1.96 or something like that for ourself, something along those lines. And you're going to get rid of the negative because we want it to hit the ground. The negative, while it's not totally invalid, in this case it is invalid because the ball was launched from a point, so you can't really go back in time in that case. If we're doing the Ferris wheel example, you could technically have a negative because you could have, we randomly started the stopwatch, and so you could have something before you started the stopwatch. But this one, you're shooting it off, so it has to be. There's no There's really no variability on this one. So this is the amount of time it's going to take, right? 3.196. That's the amount of time it's going to take to hit the ground. Okay. How far will it go? Oh, okay. How far? So we want to know, we know what the height is, not 0. So we're going to take it and plug it into the x equation, right? How far means use the x. So I have that. Okay. Right? So I'm going to take that x equation. I'm going to evaluate the x equation at 3.196. Okay, I'm going to plug that in there. Right? And you put it into that calculator, and the calculator spits out to you the answer of 265.68 feet. Okay? And again, I didn't say anything about rounding, so we're not going to worry about too much. Right? But that would be our distance that it travels.